In this video, we are going to talk about the properties of the limits. In order to talk about the properties of the limit, what I'm going to do, I'm going to consider two functions, f and g, and these two functions are defined, which simply means what? The function has a limit at x equals to a, right? Or I should say, we can define or we can find the limit of the function at x tends to a. So the limit of the function fx when x tends to a is equal to L, and the limit of the function gx when x tends to a is equal to k. So basically these two functions are defined and their values are L and k respectively. And we are also considering a constant. C. So the very first property that we want to talk about is sum. So if we want to find the limit x tends to a, and I'm adding these two functions fx plus gx, right? I'm adding these two functions fx plus gx. I will distribute the limit inside and I will write this one as limit x tends to a fx plus limit x tends to a gx, right? And as we can see, limit x tends to a fx is capital L, so I will write this one is equal to capital L plus limit x tends to a gx is capital K, so I will write L plus K. Now the second property is difference property. So we are going to take the difference or the subtraction. So let's find the limit of the difference of two functions. So I will write limit x tends to a fx minus gx, and when we want to find this kind of limit, what will I do? I will distribute the limit inside the bracket and I will write this one as limit x tends to a fx minus limit x tends to a gx, right? And as you can see, limit x tends to a fx is L and limit x tends to a gx is k. So I'm going to write this one as L minus k because I'm finding the limit of two functions when they have the difference in two functions. Or I should say, we are subtracting the two functions and then we are finding the limit of those two functions. And the limit will be L minus k. Now let's find a third property, which is product. So the limit x tends to a, inside the bracket I have fx times gx, and if I have product of two functions and I'm finding the limit, what will I do? I will distribute the limit inside and then I will separate the functions individually. So I will write this is equal to limit x tends to a fx, right, in one bracket, and then in second bracket I have limit x tends to a gx, right? And we all know that my first limit is what? L times my second limit is g, which is what? K. So the product is basically what? We are finding the limit of the first function, we are finding the limit of the second function, and then we are multiplying those two functions individually, and then we will get whatever limit we get after the multiplication. Now my third property is division. So the limit of function when we divide is limit x tends to a fx over gx is basically what? I'm going to separate the function. So the limit will be what? Limit x tends to a fx. So I'm finding the limit of numerator, which is fx, and then I'm finding the limit of the function at the denominator, which is gx. So we all know that limit x tends to a fx is L. So I will write this is equal to L over limit x tends to a gx is k. So I have L over k provided, I should write here, provided limit x tends to a gx is not equal to 0. Because if the denominator is equal to 0, then the limit of the given division or given function is not defined, because something over 0 is not defined. So we can also say that k should not be equal to 0. Now the next property that we have is constant. So the next property that we are using as a constant, or I should say we are using the next property with constant. So if I want to find the limit x tends to a any function, it doesn't matter what, and my constant is c times fx, or I can also consider my function g, and if I am doing that, I will separate the constant and I will find the limit x tends to a fx, right? And we all know that limit x tends to a fx is what? L. So I will write this one as c times L. But if we have a function gx, then we will do the same thing for the function gx. Now the next property is power. So if we want to find the limit of a function x tends to a, and I'm going to consider function as my fx, or I can also consider my gx. So I'm going to write function either fx or gx. It can be any of these two functions, and my power of that function is basically any number or real number n. So I'm going to write here as n is what? N is a real number, right? And if I have that condition and I want to find the limit of that type of function, I will find the limit of f and g. So basically when you find the limit of f, you will get L, and if you find the limit of g, you will get k. So you will get one of these two values, and my power is n, right? So this is how we will find the limit for power function. And the last property is for root function. So if I have a function limit x tends to a inside the root, and I'm going to consider fx here, what will I do? I will write the square root and find the limit of that function inside the root, right? So as you can see, I'm taking my function as fx. So the limit of fx at a is what? L. So I will write L. Now, it doesn't matter what root I have. So I'm going to make a general statement. So if I have the nth root of the function, then I can use this function exactly the same way. So my limit for the nth root of the function is nth root of L. And these are the properties of the limit that we use to find the limit of any given functions or function.